Hello students, today we are discussing some more parts from the 5th lesson of science section first, that is heat. What we discussed so far? We have discussed what is meant by heat, that is heat is energy, then latent heat, that is latent heat of fusion and latent heat of evaporation. Then we move to the regulation, then the anomalous behavior, and then we have discussed humidity, relative humidity, all the things we have discussed. And again, along with that one, units also we have discussed. Now the next point we are moving, and that next point is specific heat capacity. Before discussing this one, just try to understand this activity. We having three spheres. One sphere is made up of iron, second is of copper, and third is of lead. All these three spheres are of equal mass. Consider mass of all sphere is 10 gram each. That means each sphere is of 10 gram. That means now mass is constant. Again, we have taken one vessel, insert water within that one, kept all these three spheres within it and started to provide heat. And when temperature reaches to 100 degrees Celsius, that means all the objects, that is water, that vessel, that is container, the sphere of iron, sphere of copper and sphere of lead should have equal temperature. Now temperature is equal. Temperature of iron is equal to temperature of copper is equal to temperature of lead, that is equal to temperature of that boiling water, and that temperature is 100 degrees Celsius. Now three spheres having the same temperature. Now we have prepared a box which is made up of a little container like box. Within that one it is filled with the wax. When you are going to keep these three spheres above this one, then it starts to melt because it having the heat. The heat absorbed by the sphere is going to provide to this wax, and wax starts to melt. And because of melting, these spheres will go deep inside the wax. Now understand this one, as we have considered this demonstration, here the lead sphere's depth is little less. Then the copper sphere's depth is little more, and the highest depth acquired by the iron sphere. That means what? Who having the more heat now? Iron having the more heat, and because of the more heat of iron, the wax because of this part has melted, and so it gone deeper inside the wax. That means though they having same mass, though they having same temperature, the heat absorbed by these three spheres are different. That means at the same temperature, each object can absorb different heat. Means what? Suppose you are sitting in the class, just touch the bench, and the iron part or iron material which we having, touch that one. What you will feel? You will feel the bench, the wooden particles are little warmer than the iron particles. That means iron having less heat because it is considered, or we are observing or feeling that one as a little cooler than the wood. That means though the room temperature is same, heat absorption is different. That means amount of heat absorbed is different for the different substances, and this property is nothing but what? Specific heat capacity. That means if you are going to provide heat to different substances, if they having the same heat, they will show the different temperature. Or if we are going to consider different objects of same temperature, definitely the heat absorption is different. Then what is specific heat capacity? See here, the amount of heat energy required to raise the temperature of a unit mass. Now we should focus on this unit mass. What is unit mass? Mass is measured in kilogram, but CGS unit is gram. So unit mass is what? If it is of 1 gram. That is called as unit mass. That means you have considered any substance is of 1 gram and you want to raise the temperature of that substance by 1 degree Celsius. What is heat required? That amount of heat is nothing but a specific heat capacity of that substance. So how will you define this one? The amount of heat energy required to raise the temperature of a unit mass, that means 1 gram of that substance or that object by 1 degree Celsius, and that amount of heat is called as specific heat of that object. That means if you are going to take 1 gram of iron and the existing temperature is 20 degrees Celsius, you want to raise the temperature by 1 degree, means 20 to 21. How much heat required to raise the temperature of that 1 gram of iron by 1 degree Celsius? That amount of temperature is nothing but specific heat capacity of that iron. And what is true with iron? That is true with copper and lead. So when we move towards the next point, so this specific heat is denoted by letter C. So what is the first point to discuss for this one? The specific heat capacity of a substance is denoted by letter C. So what are the units? Its SI unit is joule per degree Celsius. What is CGS unit? It is calorie per gram degree Celsius. That means how much calorie energy required to raise the temperature of unit mass, that is 1 gram of substance by 1 degree Celsius. Then what are the examples for this? See, first example you have considered water. Water specific heat capacity is 1.0, that is 1 calorie per gram degree Celsius. Means what? If you are going to take 1 gram of water, you want to increase the temperature of that water by 1 degree Celsius, then it need 1 calorie heat. What is the specific heat capacity of iron? It is 0.110 calorie per gram degree Celsius. Means what? If you are going to take 1 gram of iron and want to increase the temperature by 1 degree Celsius, then 0.110 calorie heat is required. What about the copper? If you are going to take 1 gram of copper and want to increase the temperature by 1 degree Celsius, then this much calorie, that means 0.095 calorie heat is required to raise the temperature of that 1 gram of copper by 1 degree Celsius. So this is the part of a specific heat capacity. But this specific heat capacity, which is denoted by Q, is depend on specific heat capacity or heat absorbed by an object. Sorry for that. Heat absorbed by an object is totally depend on specific heat capacity. It is depend on mass of the object and it is depend on temperature, change in temperature. One by one we are going to discuss. See, heat absorption is more. That means to raise the temperature by 1 degree Celsius, heat is provided. If that amount is more, then definitely it will absorb more heat. So tell me, iron and copper, whose specific heat capacity is more? Iron's more. So definitely at the same temperature, iron will absorb the more heat. And copper's heat capacity is less. And so definitely as per iron, for the same degree Celsius temperature, definitely iron should have the more temperature than the more heat than the copper for the same temperature. So if specific heat capacity is more, definitely heat absorption is more. If mass is more, then heat absorption is more. See, if your mother is going to prepare a tea for 2 people, definitely heat required is less. And if the number of cup of tea increases, That means it is the 100 cup tea your mother is going to prepare. So definitely she will take more time to prepare because she has to give more heat to that vessel. That means here mass increases, definitely heat absorption also increases. So it is a direct proportion. So Q is directly proportional to C. Q is directly proportional to mass of an object. And this heat absorption is directly proportional to change in temperature. Change in temperature means what? Suppose when you have started to give heat, that temperature is T1. And when you stop that activity, the temperature is T2, that is final temperature. So delta T means difference in the temperature is T2 minus T1. Means what? Final temperature minus initial temperature. Means if you starting the activity from 20 degrees Celsius and you are going to stop the activity for 30 degrees Celsius, so 30 degree minus 20 degree, 10 degree is the difference. That is difference in the temperature. If difference in the temperature is more, you have to provide more heat. Suppose you want to raise the temperature of water of 20 degrees Celsius to 50 degrees Celsius and 20 degrees Celsius to 100 degrees Celsius. Definitely in case of 100 degrees Celsius, it will absorb more heat because it has more temperature. So finally we are reaching towards the conclusion. So heat absorption is equal to mass of object into specific heat of that object into change in temperature or difference in between the temperature. So what is true in absorption? It is also true in release of energy. That means if substance, a hot object is kept in the atmosphere, then definitely temperature starts to decrease. Why? Because the surrounding will absorb the heat from that hot object. So it is also equal. So what is heat absorbed? That is heat released. So heat released by an object is directly proportional to specific heat, directly proportional to mass of object and directly proportional to change in temperature. So what is the formula we are using for heat absorbed by an object? The same formula we should use for the heat released by an object. After discussing this, we are going towards the next point, that is one example. This example is how much heat is necessary to raise the temperature of 1 kilogram of iron from 50 degrees Celsius to 70 degrees Celsius. So see what is given. Mass of iron is 1 kilogram and specific heat of iron is 0.110 calorie per gram. So here we are having gram, here we are having kilogram. So unit should be same. So convert this one into gram. 1 kilogram means 1 into 1000, that is 1000 gram. And what is starting temperature? T1, that is initial temperature is 50 degrees Celsius and we have to stop this activity up to 70 degrees Celsius. So T2 is equal to 70 degrees Celsius. So what to find? Heat absorbed, that is Q. So what is the solution? First of all, we do not have any change in temperature. So change in temperature is equal to T2 minus T1. So 70 minus 50, that is 20 degrees Celsius. Got the point? See next one. So what is heat absorbed? Heat absorbed is equal to mass of object into specific heat of that object into change in temperature. So mass is 1000, that is gram. Specific heat, see here, 0.110. And the change in temperature is, here we having 20 degrees Celsius. So here 1, 2, 3 and here also 1, 2, 3 zeros are there. And so directly we should consider 110 into this 20. And finally we are reaching here 2200 calories. This is the heat required to raise the temperature of that 1 kg of iron from 50 degrees Celsius to 70 degrees Celsius. So what is the final answer? 2200 calorie heat it will absorb to reach the temperature 70 degrees Celsius from 50 degrees Celsius. If you want to solve this example as it is, that is only 1 kg. Nothing to bother or nothing to hesitate. See here, what to do? We should be considered as 1 kg. And here is also we should consider that is 1 kg. But answer is here, see what will be the answer. It remains as it is, that is 0.110 into 20. And so finally we are reaching here 220 and here that means here 2.200, but now here kilocalorie will be the answer.